Hello people, so we are here again to solve the problem of the day, and today we have making a large island. Okay, let's read the problem. The problem says you are given a n by n matrix grid. You are allowed to change at most one zero to be one. A group of connected ones forms an island. Two ones are connected if they share one of their sides with each other. Okay. Return the size of the largest island in the grid after applying this operation. Okay, I can say it needs much more elaboration than the question actually tells. So let's try to understand the problem with the help of the examples. Okay, so here are the same example cases. So what is actually this grid? Let me draw it here. If I have to draw, this grid actually is looking like this. Okay, this is the matrix, correct? And what are they saying? They are saying we can flip only 1 0 to 1. Okay, what do we mean by that? We can either change this 0 or we can change this 0 in the case of this matrix. And why we are changing that? To make up a larger island. And what is a large island? If you talk about this one, well, the area of this island is 1 because it is just a single cell. Similar thing goes with this one. The area of this cell is also 1, correct? But you can see that this 0 is actually linking these one, because there was one more statement written in the question. It was saying island is formed only with neighbors. And what are the neighbors? Neighbors are in 4 directions. That means if this is my sample matrix and I talk about the neighbors of this cell that is in center, it has 4 neighbors: up, down, right, and left. Okay, it has these 4 neighbors. So if we have to see this one, it has one neighbor, this 0 and this 0, and the other 2 are out of the boundary. And for this one as well, it has two neighbors, these 2, and other 2 are out of the boundary. So we have to flip 1 0 in a way that it actually connects one or more islands and it makes up a larger island. And eventually we have to give the largest island area possible, right? So in this case, as it is clearly visible, what we can do is we can flip either of the zeros, and after flipping either of the zeros, I'll get 1 here. And now you can see individually the area of this one was 1, this one was 1, but when I combined it with this this 0, which I now converted to 1, the area of complete has become 3 now, and that is what you have as your output. Okay, again, let's take this example. Now it is saying I have this grid. Okay, this grid is given to me. Now I only have one possibility here, which is okay, but thinking programmatically, you can see that this is one island, and the area that it has is 3. We cannot connect it with any other island, but we can add one block to this so that the area is increased further. The main motive is to make the largest value possible. So for this one, if I simply just change this 0, the answer would become 4. And this is what you have to return, correct? There is one more example. We'll discuss this one later. For better explanation, let me take a bigger example. So let's talk about this one. Okay, zeros are water and ones are island. What do we have to do? We have to find maximum area island. Okay, the thing is, how? First of all, if you're talking about area of islands, we should already know about the areas of existing islands, correct? Firstly, I should know that how many islands do I have, and each of the islands, what area do they have, correct? So let's talk about this 0. Assume if we are talking about this 0, how would I know, like, what is the area of this island and what is the area of this island? So for that, what I can do is I can call upon a DFS function. Okay, so what is going to be the motive of this DFS function? To get the area of island. Okay, if we have called the DFS function on any of the block that is, part of this island, it will return me the complete area of this island. Okay, this is the motive of my DFS. Fine. Once it gives me the answer, what will this 0 do? What will this 0 do? This 0 will take up 1 as the answer from this island, 4 as the answer from this island, and now 4 plus 1 is 5, correct? 4 plus 1 is 5. This 0 also has to include itself, because now this is also becoming 1. This is also part of the island. So 5 plus 1, it will become 6, correct? So combining these two islands and making a bigger island actually now is giving us 6 as the area. We have to keep on doing this. We have to keep on doing this for different islands and for all the zeros which are actually connecting. Okay, so if you talk about this 0, it is actually connecting these two islands, this island and this island, right? This island has 4 as the value. This island has 1, 2, 3, 4, 5, 6 as the value, and 1 is of itself. Now for this one, we have 3, 4, 6, 1, 2, 3, 4, and 5. All right. So for this one, we have 11 as the total number of ones, that is as the area. Fine. Similarly, we can do for this one, or we can go for this one. There are different ways, but I hope you get the idea what I'm trying to say. Every time we are traversing and we are taking up different zeros, we are actually calculating the area again and again, right? We are calling the same function, same DFS function. We might call the same DFS function like many of the times. Assume if you're talking about this 0, we need to find out the area of this island, this island. We need to make 2 calls, correct? Assume now I am going to call for this 0, right? For this 0 or for any other 0 that is in the boundary of this island. For any of the 0 that is in the boundary of this island, we would be calculating the area of this island repeatedly. And just to avoid that, we should actually run through this complete graph once, and we should store the area of all the islands possible, right? How can we do that? How can we do that? We can make a hash map for it. What will we do? Let's say I stepped on this land. Okay, I stepped on this land. I'll call my DFS, and the motive of the DFS is to get me the area. So it will get me 1. 1 will be saved, but to what corresponding value? How you are going to identify that we are talking about this island? Let's say right now, for explanation, I say I'm going to color the islands. So I colored this island red. So I'm going to say the red island is actually of 1 area. Okay. Now I'll take up this one. Once I stumbled upon this one, I will calculate the whole area, and I will say that green island is actually having 4 area. Again, let's take one more. Let me tell this is the blue island. For blue island, I have the value to be 4 again. For let's say the galaxy pen. So this is galaxy pen. For galaxy, we have 5 as the value. And now let's take gray pen. Gray island has the value to be 6. One more is left. Let me take another pen for it. Let's take a brown island. So if I mark this island brown, so what is the value of my brown island? My brown island actually is of 5 length, right? Now I have created this hash map. What is it creating? What is it actually consisting of? It is consisting of all the keys. That means all the islands and their corresponding areas. So I do not have to find it repeatedly. If I have to find it more than once, I'll simply fetch the value from here. Okay, so this is actually useful for us. Now what is going to be the approach? I've made this hash map. Now how am I going to use it? Now the thing comes that I need to travel to all the zeros. Okay, I need to travel this 0. Do I have to make any call? Well, actually I do not have to make any call, right? Because the answer will only be 1 for converting this island, right? And we can store it actually. We'll have our max variable, max area variable. Once we encounter any value, we'll save in it unless we get something more than that value. So initially I'll store 1. For this 0, what will happen? For this 0 will check all of its neighbors. What are the neighbors? 4 neighbors. This neighbor, it is water. The left neighbor is water, correct? Left neighbor is water. If we see north, if we see up, that is what? That's out of the boundary. If we see down, that is also water. Only one neighbor is land. And whenever we see that it is a land, it is actually one of the islands, right? Because we have already counted it. So we will know that this is the red island, and instantly we'll get to know that it is actually having one area. So for this one, including myself, including the 0, the area that I would have from here will be 2. This is my area. You can say local area or something, a smaller area. The thing is, we need to compare it with max. If max is smaller than that, then we will update it. Fine. Now going to this one, same thing will happen. 2 will be answered, and we do not have to update our max unless we get till here. What will happen at this 0? This 0 will check all of its 4 neighbors, and it will call DFS. Actually, it would not call DFS. We already have made the hash map. It would know that this is the part of green island. This is the part of green island, and the corresponding value it has is 4. So it would simply fetch this 4 from here, add 1. It will say that now the area has become 5. It will compare it with max area, which is 2. It will be updated. Okay, it will be updated. Now going on further, you will do the same thing from this side. The answer still will be 5. You'll do the same thing from here. The answer still will be 5. No call here, no call here, no call at this one as well. No call at here. At this point, you'll make a call. And you will get to know, this was the blue one, right? This is actually the blue island, and it is having the value to be 4. What will you do? Again, you will have 4 and you will add yourself with it, and the answer will be 5. Max won't be updated. Okay. Now everything will be going in the similar fashion, and you will go to this 0. This will also add it with this island. When you go to this 0, this will add it with this island, which is already done so many times. And for this one, this one, this one, keep on until we get to this 0, which is actually a different case. For this 0, what is happening? Well, till here, every other 0 was sharing only one boundary with any of the islands, or there was none. But this time it is actually having 2 boundaries. So it is actually having 2 boundaries. So what will we do? If we convert this 0 to 1, obviously each and every 0 is exploring all of its 4 neighbors. So this will also explore its 4 neighbors. Up is water, down is water, left is an island, right is an island. From right, what value it will get? It was a blue island. It will get 4 from here. It will get 5 from here, the galaxy island. So we have 4 plus 1 itself plus 5. Galaxy island, blue island, and the one we are converting. What is the complete value? The complete value becomes 10, right? And we'll see that, is it more than the maximum? Yes, it is. I'll convert it. Fine. Okay, everything is going well till here. Further ahead, we'll do this one. Won't be updated. Won't be updated to all this row. Once we come here, this is also a special case. Once we come at this 0, what will happen? It is sharing its boundary with 2 islands. The first island is this one, the green island. It will say 4. And this is actually gray island. Gray island is 6. And itself is 1, right? So the value has now become 11. Is it greater than the maximum? Yes, it is. We'll update the maximum. Okay. This is done. For this block, we won't have anything. This, we won't have anything until nothing here. Here, yeah, this is also a special case. See, once you come to this 0, what is this 0 doing? What is this 0 doing? This is actually sharing its boundary with 3 neighbors, right? I can say it is actually sharing its boundary with from 3 sides, but the island is 1, right? How would it identify that it is actually sharing its boundary with only 1 island? Because what it is doing, to like from all of its neighbors, it is just fetching up the answers and adding it up, adding 1 with it and returning the answer. But for this case, because this is the gray island, will it be 6 plus 6 plus 6 plus 1? Adding 6 3 times, is this the right approach? Well, it is not. That means the situation can also occur. So firstly, when we are traveling the 4 neighbors of any 0, we should make a set of it. Okay, so what I'll do, I'll travel all the neighbors, I'll make a set of it. Okay, so if I have inside my set, if I have assume I take the example of this one, so I was having green and blue. Now I was having blue and galaxy. So it will be my set blue, comma, galaxy. No changes made. Everything is fine. I will travel this set and I will calculate the values, the corresponding values of these colors. But for this condition, what will I have? I'll have my set to be, I'll have my set as gray, comma, gray, comma, gray. What is the property of set? So the property of set is actually, containing only unique values. So once the set is made, eventually I'd be having this set, having gray only one time. And that is how only one time the gray will be counted. And my answer for this one also will be 6 plus 1, correct? Remember, I only have to fetch the values from the hash map, which are present in the set. Okay, so let me discuss the flow. When we are traveling the neighbors of your node, or you can say the 0, we have four options to go to. Whichsoever option there is an island, we are going to add it up to a set, correct? And then we are going to travel the set to get the values from hash map. This is how it is going to go. So this one is also done now. And it will be having 7 as the value, and that won't be changing our max area. I hope you have understood the concept of set here. So going on to more zeros, only 7 will be the answer. No calls, repeative answers. And if we go till this one actually could be the answer, right? Because the value from this is going to be 5. The value from this is going to be 6. And actually adding 1 to it, it will become 12. And 12 is the highest value. We'll update our max again. And no matter any other 0 that we choose from here and explore its neighbors, the answer will be 12 because that is the maximum that we can connect. Okay, I hope you have gotten an idea of this question now. What are we actually going to do? I've solved it this way for you. Now let's think the flow of the code that we are going to be doing. First of all, what is the motive of my DFS? What is the motive of my DFS? The very first thing that I have to do is I have to create the hash map, correct? So for that, I have to call DFS, right? I will use a nested for loop for going to each and every block of my matrix. And whenever I encounter a land, I call my DFS function, okay? Whenever I encounter one land, I will call my DFS function and all the ones that are attached to it will be counted. So the motive of my DFS is to give back area or is to return area. But is this the only thing? Well, actually not, because we have to mark this island as well. How can we mark it? Well, we cannot practically color in our code. So just for imitating that implementation, what I can do is I can take up values. I can take up numerical values. So we already have zeros and ones inside our matrix. It is a binary matrix. Other than that, I can always take any of the integers to make up the key. So I can begin with 2. I say I encountered this island for the first time. I'll name it 2. Whatsoever island I encountered next, I'm going to be naming it 3. After that, I'll name it 4. It is the same thing as naming it red or blue or green, just like that. Okay, but this time, because we cannot practically name it colors, what we'll do is I will simply use numbers because it will be easier to implement as well. You can go this way, or even better, you can go for -1, -2, -3, and so on. This is for marking up your islands. So now what is the motive of your DFS? The motive of your DFS is to give back area and mark the island. and mark the island. And what you have to do after that, you have to maintain a hash map. And inside that hash map, you are going to be having these marks that you have put on your island as keys and corresponding to that whatsoever area it has. And you would be able to make this hash map easily. So this is the first part of the question. We are just creating up the utility that will help us to solve the question further. Now, what we have to do? So let's actually see the flow of code. Once we are done with the first step, that is once we are done with making the hash map, the next thing is to go to every zero, just like I was doing in the diagram. So I was going to each and every zero and was exploring all of its neighbors, all of the 4 neighbors, right? Then what I have to do, I had to create up a set and store all the neighbor values other than 0. So if that was not water, I had to store the symbol of it. Okay, assume this is the 0 that I am converting. This is an island and this is an island. This island is 4, this island is 2. So what I'll do, and these 2 and 4 are not the values of area. These are the values of keys of your hash map. So corresponding to 2 is actually the name of this island, 4 is actually the name of this island. It is going to be having its corresponding values, correct? We have to fetch the values then. First of all, when we are creating the set, we just have to keep up the keys. So once our set is made completely, what I will do, I will traverse the set. That means in my set, 2 will be there and 4 will be there. For this set, out of this set, I'll get the corresponding values. Assume 2 had 1 and 4 had 6. I'll get that. I'll add all the values plus 1. So I'll add all the values plus 1. This will make up my area. And once we calculated the area, we need to keep track of the maximum area and keep on updating it if we are getting bigger values of area. Once the whole matrix is done and we have traveled to each and every 0, we have seen what 0 is making the maximum area, we'll return the maximum area. So I hope now you have a clear understanding of how we are going to approach this question. And for clearer understanding, let's see the code for the same. The code is actually quite big, so I have divided the code into 2 parts. The first one is going to be the main logic about that we are using to solve the question, and then the utilities that we have made and we'll be using. Okay, so first let's go to the logic part and see. Okay, so what are we doing? We're firstly making up a color, and for color I'm taking -1. The first island I encounter, I will color it -1, and then I'll change the value of -1. Okay, I will minus it even further. The next value will be -2. So whenever I encounter the next island, its color will be -2, and -3, and on like further, how many islands I have, it will be colored like this. And these are going to be keys to my hash map. Now what am I doing? I've created one map just to keep the track of it. I've taken rows and column sizes. Then I'm doing this nested loop to go to each and every cell. I'm checking that if the cell is 1, I will call the DFS function upon it. And the DFS function has grid, I, J, and color as the parameters. Okay, what are these? I and J. I and J are for your cell. Grid is what you have to pass. You have to calculate in. Color is this one that we are talking about. Okay, once that is done, what is the motive of DFS? DFS will giving back me the area of the island that it encounters. Along with it, it will be marking the whole island. So if the island was like this before, assume this chunk was the island, all cells to be 1, all the cell will be marked as -1. Okay, and whenever you encounter any other island, let's say, let me call it the second island. When you encounter the second island, each and every value will be converted to -2. Okay, it will be -2, and like this. Fine. This is how every island will be colored and the area will be maintained. Okay. So I hope you've understood this part. Now our hash map is made. Okay. Once our hash map is done, let's go to the second part. What are we doing here is, we are going to each and every cell again. We are checking that if it is 0, I will create one set. I will get the area by default 1, because obviously if we're converting that particular 0, the minimum area is going to be 1 of itself, right? I am traversing the directions where I'll explain this for loop further on. With this loop, what we are doing, we are exploring all the 4 neighbors. we are checking that if that neighbor is valid, that means it is inside the boundary of your matrix and that it is not equal to 0, because 0 is water, 1 used to be land, but now every other land is actually having some negative value, which is the marking of it. And I'm just checking that it should not be equal to 0. It shouldn't be water. Other than that, everything is going to be an island. Okay, once I encounter this, what will I do? I'll insert that inside my set. So every value that my set will be having is going to be one key of the hash map. For that, after this thing is done, inside the same like this if is actually for 1 0 only. Okay, so for 1 0 we have calculated, we have seen all of its neighbors, we have gotten all the neighbors into the set to see if not two neighbors are actually of same island. And once that is done, I'm going to be traveling inside the set. I will be traveling the set and I will be fetching the values from the map of all the keys present inside the set. I will add them to area. One was already declared, so I do not have to explicitly add one to it now. After that, what am I doing? I'm just making my max area maximum. I'm just comparing whatsoever is bigger. If area is bigger, maximum area is bigger, the bigger value is being stored in the max area variable. Fine. So I hope you have understood it till now, right? Eventually, once the program is executed, this is also a crucial part. What is this? This is one of the corner cases. Okay. Initially, if you see maximum area, because it is a counter and it will be counting, I initialized maximum area to be 0. Now let's go back up and try to see this example that we left. This example is actually 1, 1, 1, 1, right? This is the matrix. For this, my max area is going to be 0, correct? Because I have created one map and that map has -1, which is equals to 4, right? My max area is 0. I am only updating my max area if we are interacting with any 0. For this, there is actually no 0. That means we won't be updating the maximum area as well. We won't be calling upon the neighbor. We won't be doing the process. We won't be even getting through the process. That means max area will still be 0. So in the program that we have written till now, the maximum area for this condition will also be returned as 0, which is actually wrong. So we have to take care of this particular situation, that when max area is equals to 0 and my matrix does not have any 0. Okay, that is the only way you will be having max area to be 0, correct? In that particular case, we actually have to return the size of the matrix. That means rows into column, because that whole chunk is actually one big island. Okay, so this is the corner case and we have dealt it here. So if the maximum area is 0, we are going to return rows into columns. Now you know why. And if that is not the case, we simply have to return max area. Okay, now let's see the utilities that we have made. First of all, I have made this vector of pairs, and this is just for my direction so that I can go to the neighbors. I can go to up, right, down and left. To all the 4 neighbors, these directions are marked, and I have created this function to check that if my ij or my cell is actually inside the boundary of my matrix. And this was these both the things are being used multiple times inside my DFS function as well. And when I was exploring all the neighbors of zeros, then too I used this vector directions. Okay, let's see the design of a DFS really quickly. So DFS is taking up grid ij for the cells and the color for marking. What it is doing, the very first thing it is doing is it is marking the color. Okay, and this is what it is applying the logic to calculate the area of it. Again, the answer is going to be 1, because if you're talking about the step that we are on, we have to calculate that area as well. Other than that, it will also be going on to all the 4 directions to explore the island. And whenever it finds the cell to be valid, that means the cell is inside the boundary and it is a 1. What it will do, it will call upon the DFS again, and it will give me the complete area of this island. And this is being used to create a hash map in the main logic. All right, now I think that you have a clear understanding of this question. Let's try to run this code and see if it is passing all the test cases. Okay, so here is the same code that I explained to you. Let's try to compile it. Okay, it is giving us the expected output. Let's try to submit that and test it against all the test cases. Okay, all right. So it is passing all the test cases. Great. Now I believe now you know how this question is being solved. It actually required too much code for that, but I hope now you know how the flow of the code is going on. Let's also discuss the complexity a little bit. Well, seeing the code for this part, for calculating the hash map, you actually are going to each and every cell of yours, which again is your n cross m. And for the second time too, just for exploring all the zeros, you will be going to each and every cell, right? That is n cross m plus n cross m. And for the second one too, because you have to see all the four neighbors of 0, you can say n cross m into 4, but that is a constant. So eventually you'd be having somewhere, if we are talking about a square matrix, it is going to be n square plus n square, or in general, you can term it as n square. So this is the n square solution for this problem. So I hope now you have understood this problem. And if you like this video, do mention that in the comments. I would love to hear that. Thank you.